A fire sprinkler or sprinkler head is the component of a fire sprinkler system that discharges water when the effects of a fire have been detected, such as when a predetermined temperature has been exceeded. Fire sprinklers are extensively used worldwide, with over 40 million sprinkler heads fitted each year. In buildings protected by properly designed and maintained fire sprinklers, over 99% of fires were controlled by fire sprinklers alone. History: in 1812, British inventor Sir William Congreve patented a manual sprinkler system using perforated pipes along the ceiling. When someone noticed a fire, a valve outside the building could be opened to send water through the pipes. A large furniture factory had repeatedly burned down, and Hiram Stevens Maxim was consulted on how to prevent a recurrence. As a result, Maxim invented the first automatic fire sprinkler. It would douse the areas that were on fire, and it would report the fire to the fire station. Maxim was unable to sell the idea elsewhere, but when the patent expired the idea was used. Henry S. Parmalee of New Haven, Connecticut created and installed the first automatic fire sprinkler system in 1874, using solder that melted in a fire to unplug holes in the otherwise sealed water pipes. At the time he was the president of Mathusek Piano Works. Parmalee invented his sprinkler system in response to exorbitantly high insurance rates. Parmalee patented his idea and had great success with it in the U.S. Parmalee called his invention the automatic fire extinguisher. He then traveled to Europe to demonstrate his method to stop a building fire before total destruction. His invention did not get as much attention as he had planned. Most people could not afford to install a sprinkler system. Once Parmalee realized this, he turned his efforts on educating the insurance companies about his system. He talked about how the sprinkler system would reduce the loss ratio, thus saving money for the insurance companies. He knew that he could never succeed in obtaining contracts from the business owners to install his system unless he could ensure for them a reasonable return in the form of reduced premiums. In this connection he was fortunate enough to enlist the sympathies of two men, who both had connections in the insurance industry. The first of these was Major Hesketh, who, in addition to being a cotton spinner in a large business in Bolton, was chairman of the Bolton Cotton Trades Mutual Insurance Company. The directors of this company and more particularly its secretary, Peter Kvan, took an interest in Parmalee unregistered trademark's early experiments. Hesketh got Parmalee his first order for sprinkler installations in the cotton spinning mills of John Stones and Company, at Astley Bridge, Bolton, followed soon afterwards by an order from the Alexandra Mills, owned by John Butler of the same town. Although Parmalee got 2 sales through its efforts, the Bolton Cotton Trades Mutual Insurance Company was not a very big company outside of its local area. Parmalee needed a wider influence. He found this influence in James North Lane, the manager of the Mutual Fire Insurance Corporation of Manchester. This company was founded in 1870 by the Textile Manufacturers Associations of Lancashire and Yorkshire as a protest against high insurance rates. They had a policy of encouraging risk management and more particularly the use of the most up-to-date and scientific apparatus for extinguishing fires. Even though he put tremendous effort and time into educating the masses on his sprinkler system, by 1883 only about 10 factories were protected by the Parmalee sprinkler. Back in the U.S., Frederick Grinnell, who was manufacturing the Parmalee sprinkler, designed the more effective Grinnell sprinkler. He increased sensitivity by removing the fusible joint from all contact with the water, and, by seating a valve in the center of a flexible diaphragm, he relieved the low fusing soldered joint of the strain of water pressure. By this means the valve seat was forced against the valve by the water pressure, producing a self-closing action, so that the greater the water pressure, the tighter the valve. The flexible diaphragm had a further and most important function. It caused the valve and its seat to move outwards simultaneously until the solder joint was completely severed. Grinnell got a patent for his version of the sprinkler system. He also took his invention to Europe, where it was a much bigger success than the Parmalee version. Eventually, the Parmalee system was withdrawn, which left an open path for Grinnell and his invention. U.S. regulations, fire sprinkler application and installation guidelines, and overall fire sprinkler system design guidelines, are provided by the National Fire Protection Association 13, 13D, and 13R. California and Pennsylvania require sprinklers in at least some new residential construction. Fire sprinklers can be automatic or open orifice. Automatic fire sprinklers operate at a predetermined temperature, utilizing a fusible element, a portion of which melts, or a frangible glass bulb containing liquid which breaks, allowing the plug in the orifice to be pushed out of the orifice by the water pressure in the fire sprinkler piping, resulting in water flow from the orifice. The water stream impacts a deflector, which produces a specific spray pattern designed in support of the goals of the sprinkler type. Modern sprinkler heads are designed to direct spray downwards. Spray nozzles are available to provide spray in various directions and patterns. The majority of automatic fire sprinklers operate individually in a fire. Contrary to motion picture representation, the entire sprinkler system does not activate, unless the system is a special deluge type. Open orifice sprinklers are only used in water spray systems or deluge sprinkler systems. They are identical to the automatic sprinkler on which they are based, with the heat-sensitive operating element removed. Automatic fire sprinklers utilizing frangible bulbs follow a standardized color coding convention indicating their operating temperature. Activation temperatures correspond to the type of hazard against which the sprinkler system protects. Residential occupancies are provided with a special type of fast response sprinkler with the unique goal of life safety. Operation. Each closed-head sprinkler is held closed by either a heat-sensitive glass bulb or a two-part metal link held together with fusible alloys such as wood, metal and other alloys with similar compositions. The glass bulb or link applies pressure to a pipe cap which acts as a plug which prevents water from flowing until the ambient temperature around the sprinkler reaches the design activation temperature of the individual sprinkler. Because each sprinkler activates independently when the predetermined heat level is reached, the number of sprinklers that operate is limited to only those near the fire, thereby maximizing the available water pressure over the point of fire origin. The bulb breaks as a result of the thermal expansion of the liquid inside the bulb. The time it takes before a bulb breaks is dependent on the temperature. Below the design temperature, it does not break, and above the design temperature it breaks, taking less time to break as temperature increases above the design threshold. The response time is expressed as a response time index, which typically has values between 35 and 250 mA/½ ZA/½ where a low value indicates a fast response. Under standard testing procedures, a 68°C sprinkler bulb will break within 7 to 33 seconds, depending on the RTI. The RTI can also be specified in imperial units, where 1 FTA/½ ZA/½ is equivalent to 0.55 mA/½ ZA/½ The sensitivity of a sprinkler can be negatively affected if the thermal element has been painted. From Table 6.2.5.1 NFPA 13 2007 edition indicates the maximum ceiling temperature, nominal operating temperature of the sprinkler, color of the bulb or link and the temperature classification. Types. There are several types of sprinklers: quick response, standard response, CMSA, residential, ESFR. ESFR ESFR refers to both a concept and a type of sprinkler. The concept is that fast responsive sprinklers can produce an advantage in a fire if the response is accompanied by an effective discharge density, that is, a sprinkler spray capable of fighting its way down through the fire plume in sufficient quantities to suppress the burning fuel package. The sprinkler that was developed for this concept was created for use in high rack storage. Early suppression fast response sprinkler heads were developed in the 1980s to take advantage of the latest fast response fire sprinkler technology to provide fire suppression of specific high challenge fire hazards. Prior to the introduction of these sprinklers, protection systems were designed to control fires until the arrival of the fire department. Unwanted alarms. Wet piping systems. Air trapped in the sprinkler piping can cause false alarms. To correct, bleed as much air as possible from the trapped high points of system piping. This condition can be minimized by opening the remote inspector or a Euro unregistered trademark S test valve and slowly filling the system with water when placing the system in service. Some water supplies may create surges and cause false alarms. The water flow device includes a retard or delay setting built into the switch, preventing the signal from being sent until the paddle is held forward, by water flow, for a set length of time. For wet piping systems, the time delay can be adjusted from 0 to 60 seconds. The specifications for one medical center said to set the wet piping system's water flow alarm switches at an initial setting between 20 and 30 seconds. Dry piping systems, water flow switches. Water flow switches on dry systems do not need retards as there should not be any water surges. See also, active fire protection, automatic fire suppression, building code. Fire Safety Evaluation System, Piping, Tyco International, hydraulic calculation. References. External links, http, magazine SFPE.org Whys Behind FM Global Data Sheets 2-0 and 8-9 The Whys Behind FM Global Data Sheets 2-0 and 8-9, http, Magazine SFPE or Historical Perspective Evolution Storage Sprinkler Design A historical perspective on the evolution of storage sprinkler design.